Hello everyone, welcome back to Optimization Techniques. In this session, we are going to see how we can uh, develop a box backend design in Design Expert software. We will do this by using an example, as you can see here. In this example, we are going to optimize the temperature, humidity, and light. And as you know, these three are categorized or classified as a factor for this example. And our objective, our goal is to optimize these three factors, temperature, humidity, and light, to have the maximum level of comfort in a imaginary room actually. So first, we need to select the low and high value for our factors. You can see here while factor 1 temperature, factor B humidity, factor 3 light. These three factors also you can see their units. We have two values for each one of these factors. It is according to our experience actually. Here we have selected this level low and high for each factor according to our experience that the lower values for factor A or temperature is 67 degrees Celsius. For humidity is 30 percent, and the light, which we measure the intensity of light by a unit called that lux, which is a SI unit, and what you need to know here is that it is just a unit which shows the uh, light intensity actually. And you can see the lower value which have selected for this example is 5,000. And the high value, if you remember in BBD design, we need the low and high uh, limits for each factor. So we have low limit, high limit 77 for temperature degrees Celsius, 20% for humidity, and 15,000 uh, lux for the highest limit of the uh, light. Then the center of this view will be the center point or the third level actually for each one of these factors. If you remember for in BBD design, we need to have three levels for each factors, low, high, and medium or center of those factors. You can see here we have low, high, and the center for those factors can be selected according to the low and high limits for that factor, which can be displayed by coded, which the lowest value we can show by -1, center as 0, and the high value for that factor as uh, by +1. So this is the experiment. This is the experiment matrix or matrix of experiments actually. So we need to use this uh, table. We need to go to the software and develop our uh, design and find different runs for these experiments. And also you need to notice we have three factors and one response. Response is level of comfort which it has been uh, collected or it will be collected by a questionnaire that we will ask someone to sit or in the room, and we will change the temperature, humidity, and light, each one of those factors, one factor per time. Then we will ask the person, individual, to respond to the question. How do you feel in terms of comfort level? And he will respond according to a scale from 1 to 10. He or she will select the comfort level for that room. So we have one response, which is level of comfort. Let's go to the design expert software and see how we can find the different runs and level for each one of these factors, like combination of the levels actually for each run. So let's go to the design expert software. Okay, now we are in the design expert software. As you know, we need to start the new design. Then we will go to the response surface category in the software, and we find the box taken design. Similar to what we had for CCD here, also we need to define the number of the factors, how many numeric factors we have, how many category factors which we have. Here, all of our factors are numeric factors, temperature, light, and humidity. According to their units, are numeric factor. We have three numeric factors, so we just select the two factors. The minimum number of the factors for BBD design is three factors, three numeric factors actually here. And let's enter the name, units, and low and high values for our factors. The first factor was temperature. Temperature. Its unit is degrees Celsius. Second factor is humidity. Unit is percent. And the last is light, which its unit is lux. And the minimum and the low and high values for this each one of these factor, let me just check the PDF file. We have 67 35,000. 67 35,000, and the maximum value for these factors, again we have 77 70 15,000. 77 70 15,000. Just double check here. 77 70 50,000, same like what we have in our experiment. So they have three factors. You know their units they have entered, and we know the range for each one of those factors. And here we don't have any block as well. All of the experiment will be run in one day, and also so uh, there isn't any other factor or factor like parameter which we want to ignore it. So number of block one. About center point, we can select the number of center point according to our experiment. If you notice here, as much as we increase the number of center point, number of runs, number of the experiment which we need to do will increase. So selection of this number of the center point, it's up to you. As you increase the number of the center point, the accuracy of the model optimization and so on will be higher. But you need also to notice how many runs you can have. It depends on your budget, your time, and so on. So here I just select three center point. It can be five as well. You can see how change the runs. Let me just check what I have done here. So I select three center points. I hope it gives me the accurate result or acceptable result. So here we have defined our factor day level, number of center point three now, and actually the minimum value number minimum numbers of the center point is usually 3. Then we can go to the response. We have one response, which is comfort level. We don't have any unit for that. It is a dimension less number from 1 to 10. Then we can go and see our runs here. Here it is. We have 15 runs or 15 experiments. As you can see here, the center point will automatically be used as one center, as the center of those two high and low value will be the one center point. Then number of center points, let me just uh, show a standard method. You can see here is the center point, our 3 center point. Here is center point, and here is the factors or the point which we have for design at the middle edge of the main factors, the box which we have for this design. So let me just go back. So you can see here what is the difference between run and these standard. Run means you need to go, it is a randomized structure for experiment. You need to go and run first experiment like this, then this, and as you notice here, there is a randomization between the each factors and humidity. We don't have 70, 70, 70 like what we have, here you can see standard structure. Here is constant, then this constant, and this is changing. I mean, you cannot go to the lab and run your experiment like this. It should be randomized. Then you need to follow the run order which is proposed by the software. So we have factors, you can see here. Now we need to go to the lab and to the room, ask our examinee, I can say, which they sit in the room, and ask them. Then we need to change these factors, temperature, humidity, and light, and ask that person to respond to our question about the uh, comfort level and select the one value between 1 to 10 to define the comfort level for each one of these experiments. So let's go to the lab and do this part. Okay, we went to the lab and run our experiments and collected the response for each one of these uh, treatment, or for each run. We have collected the response by the person which we asked for this experiment. So you can see the responses which we received for as much as it is higher, it means the comfort level is higher. So you can see here we have from 3 to almost 9.4. So we have collected the responses. Before we continue, let me just save the design, just save select a name for that. BB, BBD example can be an appropriate name. Save on desktop. Okay, let's continue. First, let's see a summary of our data, what we have. You can see here the response there, minimum, maximum, the coded value, which is presented by the software actually. And graph column, we have already discussed about this in CCD. It is not that much important to check all of the factors and responses here. And also here you can evaluate your data. What we need to notice here is the to check model terms. As you can see here, standard error, lower standard error is more desirable, and Ri squared, lower value for that, zero value for that is more desirable. It means there isn't any correlation between the factor which we have, and power is useless here, however, uh, and we do not use that to describe the design. And also this graph is helpful. You can see here we don't have any correlation between our factors, which is important. In other words, changing a one factor will not change the other factor. This is what we call correlation, actually. And an important graph which we have here is FDS graph, or fraction of design space graph. Actually, you can see here, what we have on the horizontal axis means we have 0 to 1. It means uh, this horizontal axis shows the design space, or a fraction of design space in each point, and the vertical line, it shows the standard error mean for that fraction of experiment. And as much as this curve is flatter, it means our design is better. In other words, as you can see here, almost just select almost 80% of our design space has this much of standard error, which is about 65 or less than, so less than 0.7. So it is helpful to see this graph and to check that. As much as it is more flattened, it means the standard error for more fraction of the design space uh, is lower. And as you can see here, up to here is flattened, and here the standard error mean is increased significantly. So what you need to check here is to see this flat shape of the curve for FDS graph. You can see also check other graph we have already discussed about that. This shape is desirable as much as it is more uh, mm, it has more toward downward the center of that, and the shape is like this is more desirable. So like this, you can check your data before we go for analysis of the data by creation the model. So next we go to the analysis tab. We go to the comfort level. The response which we have, we need to analyze each response. We have already seen in CCD design, a CCD method. We need to check each response, all of the responses one by one. Here we have only one response, so we analyze our model for our response. Response is comfort level. We do not know which type of transformation we may need. So let's start with summary. You can see here the software will check for different types of model: linear, two-factor interaction, quadratic, and cubic model. We have already discussed about that in previous lectures. It will have different terms: linear, two-factor interaction, quadratic, and cubic. We have already discussed about that. But what we usually use is the quadratic, and you can see here it is also suggested by the software. So in this table, for summary, you need to check which one of the model is suggested by the staff. Here is quadratic, and you can see here lack of fit is not significant. We will see also later. And also the difference between adjusted R square and predicted R square is less than zero point 0.2, which is desirable, uh, and you need to check that. And also about lack of fit, you can see again here in terms of the lack of fit, also quadratic model is suggested. Okay, so let's go to our model, see its terms. Here you can see, you can select, and these terms, you can see here, we have already discussed about that, what is this M, this exclamation sign, and so on. But what we have here in our model, because we have selected quadratic, which is suggested by the software, this model is more accurate than the other to find the response by using the, or predict response by using the uh, factors. You can see here, if we select quadratic, these terms will be in the model. You can see the change in that. If we select cubic, we will go to these terms. So let's just select quadratic as it is suggested by the software. Go to the ANOVA table for this model, which is really important. This table, again, you can see here, our model is significant, which is a good thing to see, and lack of it is not significant. These two should be checked always. And you can see the significant term here as well. You need to check p-values for each terms. We have main effect, interaction, and the second order effect of the each factor. So you can see here which one is significant and which one is not significant. Generally, if p-value is less than 0.05, indicate that model term is significant. Then you can come to this table and select and understand which one of these terms are significant or not. For example, here you can see that humidity is not a significant factor on the comfort level. However, the combination of the temperature and humidity as AB is marginally significant term in our equation. Usually, these significant or not significant terms show which factor is effective on the comfort level, which one is not. For example, here we understood that humidity is not effective and temperature is most effective uh, factor on the comfort level of the room. And you can see also here equation. The equation in terms of coded factor here is presented. In other words, we can use this equation to find comfort level for each unseen level for each one of these factors. For example, here the temperature we have measured is three different temperatures, but we can also here put other temperatures. Then use this model to find the comfort level for that temperature, or humidity, or the light intensity. And also we have the equation, actual equation, which we have like this. This is also important. And this table we have already checked. What you need to check in this table is three adjusted predicted R squared. Their difference is less than 0.2 is desirable, and also R squared is interestingly high, close to 1, which is also desirable characteristic for our model. We can go to diagnostic. Diagnostic section is more or less same as the CCD method. What you need to check is this box Cox plot. recommended transform. No, if it was there was any recommended transformation, we need to go to this tab and select that transformation type. Then go to the fit model, ANOVA, and analyze the that suggested transformation for the model again. So we don't need to select any transformation, and you can see here normal plot. No a strange shape. No one of the point is far from uh, the fitted curve or line actually, and also in these graphs residual with front. No strange change, high value or uh, low values out of these two boundary stations. So you can see that all of uh, these graphs for diagnostic part also are normal, and you cannot see uh, mm, any problem with our model. You can see also here, this is also important, predicted and actual value for our response. Here we have we check our model by this graph. This graph is also model, and you need to put in your report. Then we can go to the model graph. You can see this is counter plot. You can see comfort level, temperature for different temperature, and humidity. How comfortable is increased, and as much as we have a color bar here, as much as we have strong red color at most, we have higher comfort level. You can see it is a beautiful uh, figure actually. You can see here almost in the center of values for the humidity and temperature, we have highest comfort level. We can see also in 3D graph, and you can see here how comfortable is changing. As much as temperature is reduced or increased, actually temperature here, I made a mistake, temperature here is Fahrenheit. We cannot have a temperature uh, 30 degree, 70 or 67 degrees Celsius. So temperature here is Fahrenheit. And you can see here how it is changed by increase of the temperature. Low temperature, high temperature, comfort level is decreased, and only for the medium temperature or the average temperature, the temperature between the high and low, we have highest comfort level. And you can see here also in this graph how much temperature is effective on the comfort level compared with the humidity. We can have this graph for temperature and light. You can see again temperature is the main effective parameter. We can have as well for the humidity and light how it is effective. But if you notice, for this case, which we have three factors, we cannot find the optimum point by this 3D graph. If we had only two uh, factors, simply we could find that optimized point, which we are looking for the highest comfort level. But you can see here it is changing third factor. Humidity and light is here, and comfort level here is changing when I change the temperature. Even in the when we have temperature and humidity, you can see how it is changing. So we can also present combined effect. We call this combined effect of factors here, for example, temperature and humidity for in on our response. Here we have only one response. So here we have analyzed for that one response. We can have this graph for if we have more uh, responses and also more factors. Okay, now the next step is optimization method. Similar to what we had for CCD here, also we can go and select the goal for each one of our factors, we can select, we can limit the range, and also for our response, we can select the goal like maximize. We are going to have the maximum level of the comfort level. So we need to select. We select it as a maximize, and also we can select in which range of the comfort level we are interested to have that optimized or maximum amount of the comfort level. Let's see in this graph also you can see 3 to 9.4 the comfort level. If you change the limit, now the software will find the optimum point or the maximum point for the comfort level according to those three factors in this range. If I change the range, you can see also in this graph, it will just find the optimum point in this range. So let's leave it as it is. So the optimum point, the highest comfort level for these three we will select. However, we can also change the range for temperature, humidity, and light, or our factor, which we are going to find optimum point in that range as well for each one of these factors. And also we can select a goal for each one of factor as well in our optimization process. So here we leave temperature in range. So any temperature in this range from 67 to 77 degree Fahrenheit, and humidity 30 to 70%, live 5,000 to 15,000. So we do not change it. Let's see our result. And also, for responses, we can select importance level like what we had for design. Here we just leave it 3 because we have only one factor, one response, so not that much important. This one. Let's see solution. You can see here, the desirability here because we have already seen that the main effective parameter is temperature, and humidity and light are not that much effective on our result. So you can see here as well, as temperature is increased, we have higher comfort level, for example, here. And desirability for that is one. For that factor, for the response or the optimized point which we found is the maximum. Desirability is a parameter which shows how much that result is desirable. And you can see here we have 68 different optimized point, actually I can say. And we can select each one of these optimized points according to our experience because it will suggest different amounts or values for factors and also the response. Here you can see how it is changed temperature and humidity, desirability, and humidity, temperature, the counter plot for the optimized value. You can see here it is suggested by the software that the comfort level by the first solution will be 9.4 something. Second will be like this, change just a small amount. We can not see a 3D graph because we are looking for optimized point. Optimized point for each level will be different. So according to this graph, we can find the optimized point and optimized value for each one of these factors. However, the better optimization process is like what you can see here. The optimum point, for example, here we have the comfort level, the maximum comfort level, which to have this amount of comfort level, we need to have x1 temperature and humidity equal this, and also light equals to this. So if temperature is 71.8 degrees Fahrenheit, if humidity is 52 percent, and light is 5530.8 lux, we will have the maximum possible value for comfort level, which is 9.4. So by this graph also we can find the optimum point for our uh, design. It doesn't make any change if we have more factor, more response. The procedure is same like what we have done here. Maybe it may be more complicated, and also, as you can see in optimization process, your experience, your knowledge about the factors and responses is also effective on the optimization process. So for optimization process, we do not have only one specific response. Is dependent on the your experience and which one of the solution actually you selected by changing. You can see here the factor will change as well. The factor change and also comfortable change. The comfortable always trying to be maximum because we have selected. So you can see there is not that much difference between the comfortable and the maximum, uh, as it is our goal to be maximum. So we always try to be maximum according to the what we have selected for that. So the change is small changes, small differences in the details for each one of those factors. So this plot is important. These values are important. You need to select one of these as our result, as optimized point in your design. So by this, we reach the end of the video for BBD design. You can save it, and you can also take export each one of these graph, export this graph to Word like this. You can export it. It will export to the open graph. I think you can see here we have the graph here, all of the information. You need to modify the graph, however it is exported, because we have selected, the when we want to export it, we need to also select what we need to export. You can manipulate here, export as which type. It is better if you export as enhanced meta file with higher quality and export it. And if you notice, we had 15 different uh, graph because it is according to the number of graphs we have here. And this region is optimum region. If you remember, we had this region in our video lecture in theory part, which we have discussed about this optimum region. We are always looking for this optimum region in our design space. And I think it is finished, and all of what you need to run your BBD design in Design Expert software is presented in this session. You save your design, and after you can also refer back to the design in Design. Thank you very much to watch this video.